So now we'll look into what a 1, 1 onto function is. So a function f from a to b is a 1, 1 onto function if it is both 1, 1 and onto. It is a function satisfies both the 1, 1 condition and onto condition. That is, different elements in the domain should have different images, and none of the elements in the second set have to be left out. So this 1, 1 onto function is also called a bijective function, bijection, 1, 1 correspondence, or an invertible function, or a non-singular function, or a bi-uniform function. These are different names that you have for 1, 1 onto functions. So if you look at how a sample bijective function looks like. So if you take f as a function, so 1 is related to a, 2 is related to b, c is related to c, and 4 is related to d. So this is an example of a bijective function. As you can see, different elements in the domain are related to different elements in the codomain, and none of the elements in the codomain are left out. So a bijective function looks like this. So as you can see, if it is a bijective function, if f is a bijective function, the number of elements in A has to be exactly equal to the number of elements in B if the number of elements are finite. That is, if A contains 10 elements, B also has to contain 10 elements, and one element in this has correspondence to a single element in this, next element to the next element, third element to the third element, so on. So that is why this is called 1, 1 correspondence. That is, one element in this will be having correspondence to a corresponding element in the second set. Every element in the first set has 1-on-1 correspondence to an element in the second set. That is why this is called a 1, 1 correspondence. Why is it called a bijection? Because it is both injection and surjection. 1, 1 onto, it's very straightforward. And we have other names for this. These two names are used very rarely. We won't go into these names. We'll go in and see why this is called an invertible function also. Now, if a function is not 1, 1, we call it a many 1 function. If a function is not onto, we call it a into function. 1, 1, many 1, onto, into. So if a function is not 1, 1, it becomes a many 1 function. Not onto, into. So 1, 1 means different elements should have different images. Many 1 means if at least 2 elements have the same image in the second set. If at least 2 elements have the same image in the second set, we call it a many 1 function. If at least one element in the second set is left out without being paired with the first set, we call it an into function. So if you take any function, we can categorize the function into one of the 4 types: 1, 1 onto, 1, 1 into, many 1 onto, many 1 into. So if you take any function, you can keep it in one of these 4 categories. So you just need to see the nature. So if it is 1, 1, it goes into one of this, and if it is onto or into, depending on that, you can put it in different categories. So this is what you need to learn about bijective function. Now we'll go into the horizontal line test for checking whether a function is 1, 1 onto, and we'll also go into why this bijective function is also called an invertible function. Now let us look at the horizontal line test for bijective functions. The horizontal line test for bijective function says that a horizontal line drawn from any point on the codomain has to cut the graph at exactly one point. Here you have word exactly. So for 1 function, at most 1 point. For onto function, at least 1 point. For bijective function, it is exactly 1 point. For example, so if you have a graph which looks like this, you have a graph which looks like a semicircle. So this is the graph of y is equal to f of x. So if my question is, in which interval, so f is defined on what domain and what range, so that f is a bijective function. So within what domain and what range, within what domain and what codomain can this function be called a bijective function? So as we can see, if you take the domain as -1 to 1, if you take the domain as -1 to 1 and the codomain as 0 to 1, as 0 to 1. Now if you draw horizontal lines, if you draw the horizontal lines, so HLT for onto function is being satisfied, because every horizontal line cuts the curve at least 1 point, but the HLT for 1 function has not been satisfied, because 1 function says that horizontal line should cut the graph at most 1 point, not more than 1. So what I'll do is I'll restrict the domain to 0 to 1 instead of -1 to 1. So if I restrict the domain to 0 to 1 and the codomain to 0 to 1, so within this domain and within this codomain, you won't be having this graph. So this graph disappears within this domain and codomain. Now if you take only this part of the graph, this graph satisfies both the 1 nature and the onto nature. Hence, this becomes a bijective function in this domain and this codomain. So if you want to make a non-bijective function into a bijective function, it can be done by appropriate restriction of the domain and codomain. Now let us take another standard example. So y is equal to sin x. So let us initially think that this function is defined from real numbers to real numbers. Let us take the domain as real numbers and the codomain as real numbers. So let us check whether this graph is a bijective function on this domain and codomain. We know the graph of y is equal to sin x. So it looks something like this. Now, first, is it a 1 function? Is it a 1 function? So let us do the horizontal line test for 1 function. What does it say? If you draw a horizontal line at any point on its codomain, it has to cut the graph at most 1 point. It is not more than 1 point. So as you can see, if you draw a horizontal line, this horizontal line is cutting the graph at infinitely many points. So this y is equal to sin x is not a 1 function. Is it an onto function? So let us see. Onto function says that every horizontal line has to cut the graph at least 1 point. So any number of points more than 1 is okay. But so this happens if the horizontal line is drawn between -1 and 1. So if I draw a horizontal line beyond 1, this horizontal line will not cut this curve. So at least 1 point condition is also not valid. So y is equal to sin x on this domain and on this codomain is neither 1 nor onto. So first, to make this an onto function, first let us restrict the codomain. So we have to make codomain equal to the range of this function. What is the range of sin x? -1 to 1. So if you make the codomain into -1 to 1 instead of real numbers, if you make the codomain into -1 to 1, then codomain will be equal to range, hence this becomes an onto function. This becomes a onto function. Now, how do I make it a 1-1 function? Because what is the problem with 1-1 function? If you draw a horizontal line, it is cutting the graph at infinitely many points. But I want the cutting to be at 1 or less points. So what I do is, I can do appropriate restriction of domain. So if I restrict the domain from -π/2 to +π/2. If I restrict the domain of sin x from -π/2 to π/2. So all the remaining graph beyond π/2 and beyond -π/2 will be disappear. So if I consider the domain only as -π/2 to π/2 within this domain. So you have only this graph. So you have only this graph, all the remaining graph will be disappearing. So if you take this graph between -π/2 to π/2, will it satisfy the horizontal line test for 1-1 function? Yes. So every horizontal line cuts the red part at 1 and only 1 point. So this red part satisfies the condition for bijective function. Hence y is equal to sin x from -π/2 to π/2 to -1 to 1 is a bijective function. Again, it is not necessary that you have to do only this restriction. Even if you restrict the domain to -3π/2 to -π/2. So if you restrict the domain to this, then also it is a bijective function. π/2 to 3π/2, it is also a bijective function. So you can have different restrictions to make a function into a bijective function.